Hey everyone, I would invite Himanshu sir to start the session.
Good morning, everyone.
Good morning, sir.
Okay. In in the last class, what we were discussing about? We were discussing about the IUPAC of different functional group. Okay. So today onwards, I told you that we have discussed the priority order. Okay. So have you learned that?
Yes, sir.
Very good. Okay. So tell me, nitrile or anhydride, which have more priority?
Anhydride, sir.
Anhydride. Very good. And thiol versus amides. Thiol
Amide.
versus amides. What one? Amides. Very good. Okay. So just remember this thing. Okay. So let's start with the IUPAC of polyfunctional compound. IUPAC names for polyfunctional compound. So first example I'm taking, and then you have to give. First I'll do, then I'll give you 5 to 6. You have to do, and then we'll discuss that 5 to 6. Okay. So first one is CH3 CHOH single bond, CH2 single bond, CH2 single bond, COH. Okay, this is a first example. See, first what you have to do, you have to select the longest chain. Second thing, you can see that here two functional groups are present. One is alcohol, another one is carboxylic acid. See, this one is alcoholic group, this one is carboxylic acid. So we have two functional group. So first you have to see that which functional group have the higher priority. So which one have the higher priority?
Carboxylic acid, sir.
Carboxylic acid. So you have to do the numbering from the side of the higher priority group. 1, 2, 3, 4, 5. Okay. So 5, and on the fourth position, what we have? OH. So OH will be in the prefix. So it will be 4 hydroxy. 1, 2, 3, 4, 5 carbon are there. For 5 carbon, what we use pentanoic acid. Clear?
Yes, sir.
So do you know that what you have to write in prefix if any of the functional group is coming? Okay, let me tell you. Remember this thing, whatever I'm telling you right now. If COH carboxylic group is present, this is prefix. Okay, carboxylic acid, then you will use carboxy in the prefix. If that cyanide CONS2 is present, amide, then you'll write carbamoyl. I'm telling you main, then you can go for the book. Then if C triple bond and cyanide is present, then in the prefix it is known as cyano. If aldehyde is present, you will write formyl. If ketone is present, then you will write keto. If OH hydroxy is present, alcohol is present, then you write hydroxy. If NH2 group is present, you will write amine. Okay. If NO2 group is present, you will write nitro. What else? If halogen is present, halogen is always come in the prefix, so it will be considered as halo. It will be chloro, bromo, iodo. We can use like this. Okay. So at least remember these. If you, while doing the nomenclature, uh, if you fail to remember any of the compound, any of the functional group, you can ask me. Okay. So let's start. CH3 C double bond O single bond CH2 single bond CH2 single bond COH. I'm writing few examples. You have to tell. Another one is CH3. You can start doing CH3 CH NH2 CH2 CH OH CH3. Next example CH3 C above CH3 below CH3 C double bond O single bond CH3. Right here multifunctional group is added, so it will be OH. Okay, just write the name of these three first, then we'll go further. Time is 5:12. You have 2 minutes. 5:14. I'll start doing it by myself. Yes, done. Okay, let's start with the first one. First one, name. Anyone? Okay, just tell me which groups are present. One is
Ketone.
carboxylic and one is ketone.
Okay.
Okay, the name should be done from the side, from the bigger functional group, having the higher priority. Now tell me the name.
4-keto-bentonic acid, sir.
Okay, I told you keto here, but basically we use oxo. We'll use oxo, not keto. It's okay. 4 oxo. Rest was the rest. 5 carbon is there, and COH group.
Acid.
Yeah, pentanoic acid. Pentanoic acid. Okay. Next one. Numbering right side, left side.
So NH2 is amine, sir.
It's a mine.
I mean, in priority order, you don't have given amine.
In priority order, after that, when I wrote that particular priority order, I told you that after this, all the remaining functional group are treated as substituent. So they are having the lesser priority. Okay, so those I have mentioned in the priority order, they are the main one. The rest you'll consider as the you can say substituent. So they are having the lesser priority as compared to the one having the they will have less than the functional group which are present in the that priority order. So NH2 is having the lesser priority. So now you will do the numbering from the right hand side. 1,
Yes, sir.
2, 3, 4, 5. Name will be 4 amino. 5 carbon, then
Pentanol.
pentane. But we cannot write pentanol directly just because OH is not on the terminal carbon. On the last carbon, it's not present. So it's present on the second carbon, so it will be pentane 2 all. Clear?
Yes, sir.
Okay. Next one.
OH and ketone.
Alcohol and ketone. Yes, anyone else also speak it up. Functional group, which one is higher? Ketone or alcohol?
Ketone, sir.
Ketone. The numbering should be done from the side where functional group is near. 1, 2, 3, 4. Now tell me the name. See, we have this hydroxy, we have this methyl, but we have to write alphabetical order. Then the name will be
2-hydroxy and 2-methyl.
why 2?
Oh, sorry, sir. 3.
3. 3 hydroxy, then
3-methyl.
3 methyl, yeah. Then 4 carbon, then butane.
Butadiene.
Second position, it's ketone, 2, and then you write one at the end. The name will be 3-hydroxy 3-methyl butane 2-one. Clear? Okay, I'm giving you one more example. I'll give you two more examples. Okay. CH triple bond C single bond CH above it CH3, then CH, here we have OH, then CH2, then COCl. Yes. First of all, which functional group?
Alcohol and ketone.
Alcohol and ketone. Ketone and alcohol. Alcohol is correct, but just look at the last
Yeah, sir. It is acid chloride.
acid chloride. Very good. See, this is the difference. I told you earlier also, it was Cl with the Cu bond, so it's known as acid chloride. Okay. Speak up. Okay. I'm doing the number. 1, 2, 3, 4, 5, 6. Now speak. On third position, what we have? Hydroxy. So it will be 3 hydroxy. Then on the fourth position, we have methyl. Then it will be 4 methyl. Then we have 6 carbon. So we'll use hex. But on the fifth position, we have triple bond. Then 5. Then we have Just for the triple bond, we use YNE. So we'll not use E at the last. 5-ine. Then on the first position, we have oil and chloride. The name will be 3-hydroxy 4-methyl hex 5-ine 1 oil chloride. Clear?
Yes, sir.
Okay. But what will you do when you're having two similar functional groups? For example, COOH, then CH, double bond CH, single bond COOH. Now just try to name it. See, in this particular case, you can give the priority to any of the compound, that is any of the functional group, just because both are same and both are on the equal distance. It will be 1, 2, 3, 4. Now, for carbon, what we use? Bute.
Beauty.
On the second position, we have
Double bond.
double bond. Then for double bond, we use ene, then dash. Then on the first and fourth position, we have COH group. And for the COH group, we use oic acid. Since we have two COH, so I'll use dioic. Then we'll go for acid. Butene 1,4-dioic acid. Clear?
Yes, sir.
Yes, sir.
One compound I'm making is COH, then CH2, then CH2, then CH, then CH2, then CH2, then COH, and one COH over here also. Now, in this case, you will not give priority to anyone. All are having the equal priority because all are same group. So you'll use the main chain, and main chain will be considered as this one. Okay, so I'll do the numbering. Just see 1, 2, 3, 4, 5. You can do either from the left side, you can do from the right side. You don't need to take the C of any of the carbon, just because if you can take the right one or left one, but how you'll take this one? It means you're not going to be giving priority to this carboxylic group. Okay, so you'll not count the carbon of any of the functional group. The 5 carbon is present in the main chain. So for 5 carbon, we use at pentane. Then 1, 3, 5. 3 position we have COOH group. And you'll use tri, just because 3. Then carboxylic acid. Here carboxylic represents COH. So 3, it means tri. So tri-carboxylic acid, that's it.
Sir,
Yes.
in the before question, we have written dioic acid, and now
Yeah.
we are writing carboxylic. Can't we write oic acid?
Trioic acid we can write, but right in this first example, I have mentioned the carbon also in the main chain, bute 1, 2, 3, 4. But in this particular case, I have not mentioned the carbon in the main chain. So that time, just because I was mentioning that carbon, so I use oic acid. But right now, since I'm not using not using this carbon, so I'll write carboxylic acid. That I told you the carboxylic word represent that COH group is present. So if you are not mentioning it, then you'll write carboxylic acid. Okay, and sometimes what people do, sometimes people do the naming like 1, 2, 3, 4, 5, 6, and 7, and that is 7 carbon, and the third position that is COH. So some people do 3 carboxy heptanoic acid, 3-carboxy, not heptanoic acid. 3-carboxy. 1 comma 6 dioic acid. But this is the wrong way. You'll not use this. Okay. So just if all the same group are present, so you'll not give the priority to anyone. So don't do these kind of things. Remember, if you're not counting, then you'll write COOH. And there's no other way. If you can do another way, then let me know first. Maybe. Possibility. Anything. Any other idea? Yes, Vignesh.
No, sir.
Okay. One more order. You have to remember that first you'll do the principal functional group according to what we have done 4 examples. So according to first you'll do the principal functional group priority, then you'll go for the double bond, then you'll go for the triple bond, then substituent. Okay, so this is the priority order. Wait, this is the priority order. If you want to write, you can write. Okay, let's move further for the one more example. Done? Okay. Now do the numbering and do the naming. Whatever you were telling Vignesh that can't we write oic acid? In the earlier, we were using these kind of system, like writing the oic acid instead of carboxylic acid. But now it's being changed. We have to write carboxylic acid.
Okay, sir.
Okay. Anyone name? Okay, I'm doing now. Yes. The numbering you can do from any of the side. 1, 2, 3. Will not give priority to any of the carboxylic group. So on the second position we have hydroxy. So we'll write 2-hydroxy. On the first, second, and third, all position we have carboxylic group. Since they have equal priority, will not give to anyone. So first we'll write the name of main chain. So 4-hydroxypropane dash 1 comma 2 comma 3. For 3 we use tri carboxylic acid. Done? Any doubt? Any doubt?
No, sir.
Okay. Let's start with the nomenclature of bond line compound. See how you have to do. Okay. This sort of compound can be asked. Okay. Now, anyone who can tell the name, just remember at each corner, at each end, we have carbon. Just count. 1,
Oxygen.
2, 3, 4, 5, 6, 7, 8. All single bond. We have oct, single bond ane. Name is octane. Clear?
Yes, sir.
Let's do the naming of this compound. Yes, name. See, those who are having a sort of problem in this is in the rough you can make a structure. So 1, 2, 3, 4, 5, 6, 7 carbon is present. Okay, so it will be CS, not CS3. First make 7 carbon. 1, 2, 3, 4, 5, 6, and 7. On the first there is a double bond, then double bond, then again double bond. 1, 2, 1, 2, double bond. And 3, 4. Okay, then 3, 4. You have to leave 1. Then 1, then leave 1. Okay, this is the pattern. Then here will be CH2. We have CH, 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 CH2. See, just calculate the hydrogen. If there is wrong, you can write the hydrogen. Okay, now you can do the numbering, do the naming. 7 carbon is present. 7 carbon is will be hept on the first position, on the third position, and on the fifth position. We have double bond. The hept dash 1 comma 3 comma 5. 3 triple double bond, then tri, then ene. That's it. So these are sort of bond line notation. One more example you want to do? Okay.
So
Yes.
I don't get how you written hydrogen.
See, each carbon make 4 bond. Each carbon was making the 4 bond. See, I'm doing it again. First make the 7 carbon. 1, 2, 3, 4, 5, 6, 7. There is a possibility maybe I have mentioned more or less. Okay. So 7 carbons are present. So first mention the double bond. On the first position, double bond is there. On the third position and then on the fifth position, we have double bond. Each carbon make 4 bond. So if you see for the first carbon, already 2 bonds is there. So you'll add 2 more hydrogen. 4 completed bond. On the second one, 3 bonds are made. 1, 2, and 3. Left side 2, right side 1. So we'll give 1 hydrogen. Then again, 1 hydrogen. Why? 2, 1, 3. And 1 hydrogen I've given. I'll give 4 bond. Again for this carbon, 3 bonds are already there. 1 more hydrogen is given. Again for this same. Again for this same. But at the last one, okay, last one will have CS3. If this particular carbon is making 1 bond, so it will be CS3. So valency of carbon is 4, so it will make 4 bonds. In the starting of the chapter, I told you that it is tetravalent in nature. Got my point, Vignesh?
Yes, sir.
Okay, now do the numbering of this particular compound. Naming of this compound. See, first carbon, second carbon, third carbon, fourth carbon, fifth carbon. And on the third carbon, we have this methyl. See, if something happen like something is like this, then you know that it's a methyl group. Okay, so we'll do the naming. On the first position, we have bromo. So one bromo. Then dash on the third position, we have methyl. Then 5 carbon is present, so it is pentane. On the third position, or the second position, on the second position, ketonic group is present on the second position, 2, and ketone we use one. So 1 bromo, 3 methyl, pentane, 2 one. So the example will be like this, okay? So don't get confused. Let's start with the nomenclature of cyclic compound with the rules, with the examples simultaneously. Nomenclature of what? Of cyclic compound. Anyone have any idea having about any knowledge regarding cyclic compound nomenclature? No. Okay. First of all, what is cyclic compound? Those compounds which are forming a ring. It means a sort of closed structure is present. If closed structure is present, it means you are talking about the ring. Okay. So let's start with 111 rule and with the example. First rule is then you have to add cyclo. You have to add cyclo before the name. Okay. For example, this compound is present. How many carbon is present? How many carbon is present?
3.
3. So if 3 carbon is present, first you'll add cyclo.
5.
Then for 3 carbon we use propane, cyclopropane. That's it. Okay. Okay. Tell me the name of this compound.
Cyclobutane.
Cyclobutane.
Okay. Second rule is if a substituent or alkyl group are present, then you will do the numbering in the alphabetical order. If substituent or alkyl group are present, numbering should be in alphabetical order. Okay. So let's take example. Okay. The numbering, then let's start with the CS3. 1, 2, 3. Write the name. On this third position, we have ethyl. On the first position, we have 2-methyl group. Okay. So, how you will do the numbering? Okay. If anyone is having confusion why I have took the from this why I have started the CS3, minimum set of locant you can use 1 plus 1 2, then 3 1 plus 1 plus 3 or 3 plus 1 plus 1. Or okay, it will be same, but you will give the priority to the CS3 just because on the same carbon we have 2 CS3 group. Okay. So later on, if you start doing these things, you'll get why I'm doing these kind of things. So on the third position, we have 3 ethyl. On the first position, what we have? Methyl. So it will be 1, 1 dimethyl. And for the cyclic, we'll use cyclo. 6 carbon is present, so it will be hexane. All this much easy is not asked. Third rule. Third rule is if a ring is containing more or equal number of carbon atom, then the attached if ring and alkyl chain have equal number of carbon. Have the equal number of carbon. Then alkyl group is treated as substituent. It means, see, example, CH2, 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 CH3. Now, if you'll see in this chain, we have 5 carbon, 1, 2, 3, 4, 5. While in the ring, 1, 2, 3, 4, 5 carbon are present. So, if ring and that chain has equal number of carbon, then the parent group will be the cyclic compound, and you will write the side chain as the substituent. So for the 5 carbon we use pent, and if they are coming in the side chain it will be pentyl. So this is considered as pentyl. And on the ring is cyclic in nature, so you'll write cyclopentane, pentyl cyclopentane. Clear? Clear? If doubt, then ask in this point.
Sir, can you explain again?
Okay, I told that if this side chain, see, this is alkyl group and this is the cyclic part. If they are having equal number of carbon, see, 1, 2, 3, 4, 5 carbon are present in the chain, and 1, 2, 3, 4, 5 carbon present in the ring. If they are having the equal number of carbon, then this chain portion will become in the as the substituent. So I have named it as pentyl in the starting. But that ring will be considered as the parent chain, parent group. Parent group is the one which we write at the end. So this is considered as the first case of third point. When they are having the equal number of carbon, you will give the priority as the parent to a ring. Ring will get the priority and it will be written at the end. Okay. But the second condition is if side chain have lesser number of carbon but have multiple bond. It means side chain is having lesser number of carbon or have the equal number of carbon, lesser or equal you can write, but having the multiple bond. Then what you will do? See, the example is like in the ring we have how many carbon?
3.
3. And if I'll add CH2, CH double bond, CH2. Now in the side chain we have also 3 carbon, or it means you can say the group attached with the ring having the 3 carbon also. So they both are having the equal carbon. Now we cannot use that rule, above rule, that you will give priority to the side chain. No. Why? Because this chain contains a multiple bond. So now priority is given to alkyl part. Alkyl part, it means the chain. So now you will do the numbering from the side from where the double bond is coming near. So if you'll see 1, 2, 3. On the first position, we know that we have double bond, and on the third position of this carbon, we have this group attached. So first we'll write cyclo. Okay. And which position? Third position, 3 cyclo. 3 carbon is known as propane, but since it is coming in the side chain, we will use propyl, 3 cyclopropyl. In the main chain, we have 3 carbon. So we'll use, for the 3 carbon, we use prop. Then on the first position, we have double bond. Then we'll go for the ene. So it will be 3 cyclopropyl prop 1 ene. Clear the difference between these two? If confusing, then ask. I can repeat it again if you want me to. Clear?
So can you repeat the B point once again?
B point is if the alkyl part is containing multiple bond, either it can be double or it can be triple. If the alkyl part is the one having the chain. Okay, so if the alkyl part is having double or triple bond, then what will happen? You will give priority to that particular chain, even if the number of carbon in the main chain is more. And if they are having the equal carbon, you'll give the same thing. So these two are having 3 carbon in, while see in this particular chain we have 3 carbon, in this cyclic compound we have 3 carbon. But just because this alkyl part had double bond, I gave priority to the double bond. So I named this portion of ring first. So on the third position it was cyclic compound, so I write 3 cyclo. And since this is containing 3 carbons, so I write propyl. I have to write the propane, but it is in the side chain, so I have to write propyl. Then 3 carbon is present in the main chain, so prop. Then on the first position we have double bond and then ene. So now you got my point or not?
Yes, sir.
One more category is there in this third point. C category. What you will do in this case? Now what you will do? You will give priority to no one, no ring. Both the ring will come as the side chain because both ring are containing equal number of carbon. If both ring are containing equal number of carbon, then they will not get the priority. They will come in the side chain. So see how I'm writing the name. See, first tell me, uh, this ring is containing how many carbon? 3 carbon. So I'll write as cyclo.
Prop.
Cyclo, yes. Repeat.
Cyclopropane.
Propane. But if it will come in side chain, then what you'll write? Cyclo.
Propyl.
Propyl.
Propyl. So cyclo propyl. And how many rings are present?
2.
2.
So I will write di in the starting. So dicyclopropyl. And how many chains are present? How many carbon present in the main chain?
1.
1. And containing the single bond. So methane. Dicyclopropyl methane. Now got my point?
Yes, sir.
Okay. Now let's start with the fourth rule. What fourth rule say? Fourth rule say that if double bond is present in the ring, if double bond is in the ring, then numbering should be done in such a way that multiple bond gets lower number. Double bond should be the numbering should be done in such a way that the double bond will get the lower number. So just look at what I'm doing. Now the numbering should be done from where the multiple bond will get the lower number. The numbering I'm doing will be 1, 2, 3. Now double bond is in the first position. Okay. On second and third position, what we have? We have methyl 2, 3. Just because we have 2, then we'll use di. And for the 2, what we use? Di, and then we'll go for the methyl. 5 carbon are present in the main chain, and since it is a cyclo, so we'll first use cyclo. Then for the 5 carbon, we will use pent. Then in the first position, we have double bond. So pent-ene. Got it? Yes or not? Fast.
Yes, sir.
Okay. Let's move with the fifth point. What fifth point say? Fifth point say if ring contain double bond and side chain contain functional group, then the ring is treated as substituent. Condition is ring have what ring have? Double bond and side chain have functional group. Ring have double bond and side chain have functional group. Then the ring will be considered as substituent. Okay, so now let's see the example. Now the ring is having the double bond. Yes or not?
Yes, sir.
So which side should I give the priority according to the above rule? See, there is none of the matter of the side chain right now. The matter is of functional group. Functional group is present in the side chain. So I'll do the numbering from the side chain first. Okay, see how I'm doing the naming. First, second, third. So this all will considered as the substituent. So this is the main chain of 3 carbon. Now you will do the separate naming of this side chain. So how you will do? It will be 1, 2, 3, and then 4. You'll write the name like, see, on the main chain, this particular substituent is added on the third position. So it will be 3. You'll write 3 first, just because all the substituent is on the third position. 3. Then you'll write dash. Then you'll use parenthesis. Then on the fourth position in this ring, we have what we have on the fourth position in the ring.
Methyl.
Methyl. And then what we have? We have a ring. And ring, we use cyclo. Then hex. Then on the second position, we have double bond in the ring. The 2-ene. And then the first position, just because it is side chain, we'll use "-ile". So this is the name of this substituent. Then you will write the name of The parent chain. Parent chain is having 3 carbon. For the 3 carbon, what you use? Propane. And since COOH group is present, you'll write oic acid. So the name will be 3-4-methyl cyclohex 2 in 1-ionyl propanoic acid. Any confusion? See, if confusion, then don't keep your mouth quiet. Just speak. Then only there's a possibility that you can learn this thing. Say I'm repeating this point. If the ring is containing double bond, side chain is containing the functional group, then the priority must be given to this particular side chain, and rest will be considered as substituent just because the bigger functional group is present. Okay, just I'm giving a basic example. What I used to say, that if the grandfather is present in the home, then he is the master head. If he is not present, then father is the master head. If father is not present, then you are the master head. So if the bigger functional group is present, then the priority should be given to that particular thing which have the bigger functional group. COH is the biggest functional group over here. So this is the priority. This will come at the end. This will come at the end. Rest, this is considered as side chain. In side chain, what we have to do? We have to start the numbering from the carbon of the main chain. So 1, 2, 3, 4. On the 4th position, we are having the methyl group. So 4-methyl. While on the 2nd position, we have double bond. So since it is cyclic, so we'll use cyclo. 6 carbon, we'll use hex. On the 2nd position, it was double bond, so I have used 2-ene. On the 1st position, is this considered side chain? If you'll not use 1-YL, you can directly use enyl, ENYL. It's okay. Okay. And at the last, 3 carbon, propane. And just because of the COH group, I used oic acid, propanoic acid. Step by step, you have to go. Clear? Do one thing. Just process this thing again in your mind. Just because if you'll not process, I cannot go for the second rule. We have 5 more rules. Clear this point? You can do one thing. You can see this video again, and just if you have confusion, just repeat that twice, thrice. And if you have doubt, ask me tomorrow. Okay. Next point, 6th point. Okay, this will be the last point from my side for today. We have 2 parts in this. First part, if I'll go, if the ring and side chain both have functional group. If a ring and side chain both have functional group. Both have functional group. Then whom should you give the priority? The priority should be given to the bigger functional group. Priority to bigger functional group. Bigger functional group means like having the highest priority in the priority order. So I'm giving one example. So just see this particular example. In this particular compound, you can see that the ring is having the ring is having N2O group, NO2 group, while the main chain is having the COH group. So which one is the bigger, NO2 or COH? Yes, Vignesh. Which one is bigger? COH or N2O?
I think COH.
Yes, COH. I've told you the priority order now. So if COH is a bigger functional group, then priority should be given to this one. 1, 2, 3. So this is considered as the parent chain. Parent chain. And this will be considered as substituent. So you'll start doing the numbering from this side. 1, 2, 3, 4. On the fourth position, we have nitro. Okay, now you'll write the name. On the third position, we have this substituent, so it will be 3, then 4, nitro, 6 carbon is present, and cyclic, then cyclo. For the 6 carbon, what we use? We use hex. Then on the second position in the ring, what we have? We have this double bond. So hex 2, wait, yeah, hex 2 in 1 aisle, just because it's a side chain. In the main chain, we have 3 carbon. So for 3 carbon, what we use? Prop. Then on the second position, we have double bond, 2 in, then 1 oic acid. So first I have mentioned the name of this substituent. So from there here to here, this is the name of substituent. Then side chain is this one. Clear?
Yes, sir.
Okay. Then last point, B part of this point, that if both contain the same functional group, if ring and side chain contain similar functional group, then what you will do? Priority will be given to ring. Priority will be given to ring. Last example for today's class. Benzene, cyclohexane. Over it I'm writing CH2, CH, then OH, CH2, CH3. So, see, both the compound is containing OH group. So, similar functional group is present in the side chain as well as in the ring. But if something happened like this, then you'll get the priority. You'll give the priority to the ring. You'll give priority to the cyclic compound. So this will be named at last, and this will be named at first. So you'll see this. Now do the numbering. 1, 2, 3, 4. 1, 2, 3, 4. On the second position, we have, what we have? 2 hydroxy. 2 hydroxy. Then 4 carbon is present. Then it will be but. Since it is a side chain, you'll use butyl. You'll put this in parenthesis. Cyclic string is present, so cyclo. And when OH group is present, we called it as all. And 6 carbon, so cyclohexanol. So the second position of the chain, we have OH, the 2 hydroxy, 4 carbon is present. Then we'll use butyl. Since this ring contains 6 carbon and ring is cyclic, so that's cyclohexane. Since OH group is present, so I'm using OL, cyclohexanol. Clear?
Yes, sir.
Okay, just remember this much point today only. Just because I know that this is new for you and this will go a lot. Okay, just go through this video on this YouTube link again so that you can revise it. Tomorrow we'll start with the another remaining rules, and we'll start the nomenclature of the aromatic compounds also. I'll try to finish it tomorrow. Most probably I'll finish, but I just want you to revise this class first. Then only you'll be able to do the nomenclature of the aromatic compounds. Okay. So let's meet you now tomorrow or maybe in the evening. If any extra class will be there, then just please revise it. Okay. Gayatri, today you were not saying, and not even any other. So students, just try to speak. Okay. So you can join the next session now. See you tomorrow. Thank you so much. Yes, students, just leave this class and join the next session.